1900万 USDT， 有5700万。
Welcome to Summoner's Rift. "30 seconds until minions spawn. First blood."
Nothing can hold me back.
An ally has been slain.
Now I'm angry.
Minions have spawned.
Stampede. Away. Must follow. Now I'm angry. Nothing can hold me back.
An ally has been slain. An enemy has been slain. An enemy has been slain. An enemy has been slain.
Now I'm angry.
Slain an enemy. Shut down.
Nothing can hold me back.
An enemy has been slain. An enemy has been slain.
I know the way. Nothing can
Ally has been slain. You have slain an enemy has been slain. Killing spree. Aced. Killing spree.
Nothing can hold me back. Now I'm angry. Stampede.
Rampage. Destroyed a turret.
I know the way.
Unstoppable. Dominating.
Now I'm angry. must follow.
Has destroyed a turret. Your team has destroyed an inhibitor. Double kill. An enemy has been slain. An enemy has been slain.
Stampede!
Unstoppable. Enemy quadra kill.
Now I'm angry. Stampede!
An enemy has been slain. Shut down.
Must
Enemy double kill.
I know the way. Stampede! Nothing can hold me back.
Enemy double kill. Double kill.
You must follow.
Dominating.
I'm angry.
An enemy has been slain. An ally has been slain. An enemy has been slain. An ally has been slain. ally has been slain.
You must fall. Nothing can hold me. Nothing can hold me. I know I know the way.
An ally has been slain.
You must follow.
Shut down. Has been slain.
Nothing can hold me back.
Ally has been slain. An enemy has been slain. An enemy has been slain. An ally has been slain.
I know the way. Nothing can hold me back.
The enemy's inhibitor is respawning soon. The enemy's You have been slain. Victory!
my will, this shall be finished. Find me greater foes.
Minions spawn. An enemy has been slain. An ally has been slain. An enemy has been slain. Minions have spawned. Double kill. Enemy minions spawned.
For my father, the king.
Name's Ezreal.
Protect the faithful. Righteous retribution. Stand with me, brothers and sisters.
An enemy has been slain. Shut down. Enemy double kill.
Find me greater foes.
An ally has been slain. An enemy has been slain. Shut down. Double kill.
No quarter for the wicked. Protect the faithful.
An enemy has been slain.
Stand with me, brothers and sisters.
An enemy has been slain. Enemy rampage. Enemy double kill.
Today is a good day to die.
An enemy has been slain. Shut down. Killing spree.
The master, now and forever. I will not falter! We shall rest when we are dead.
Rampage.
Find me greater.
Unstoppable. Turret plating will fall soon. Is gorgeous. Enemy double kill.
Topple their force.
Shut down. You have slain an enemy. Shut down.
To do and die.
An enemy has been slain. Down. Destroyed. Shut down.
Who dares defy my will?
Your team has destroyed. An enemy has been slain.
Stand with me, brother. Demacia, now and forever.
An enemy has been slain.
We shall rest when we are dead.
An ally has been slain. An enemy has been slain. Double kill. An enemy has been slain. Shut down.
Order for the wicked.
Shut down. Your turret has been destroyed.
Who dares defy my will?
Enemy killing spree. Enemy double kill.
Righteous retribution.
An enemy.
I love it.
team has destroyed an enemy has been slain.
Part of the kill, part
An
of the
enemy
gold.
is unstoppable. Shut down.
Protect the faithful.
An enemy has been slain.
Brothers and sisters.
Your turret has been destroyed.
Today is a good day to die.
Shut down. An enemy has been slain. An ally has been slain. An enemy has been slain.
We shall rest where we are dead.
Shut down. Been slain. An enemy has been slain. Killing spree. Killing spree. An enemy has been slain.
Find me greater foes. No quarter for the weak. Who dares defy my will?
You have slain an enemy. An ally has been slain. An enemy has been slain. Double kill. An ally has been slain.
Stand with me, brothers and sisters.
Your team has destroyed a turret.
greater foes.
Enemy killing spree. Shut down. Ace.
No quarter for the wicked.
Your team has destroyed the turret.
Who dares defy my will?
You have slain an enemy. An enemy has been slain.
Faithful. Stand with me, brothers and sisters.
An enemy has been slain. An ally has been slain.
Today is a good day to die.
Your turret has been destroyed. Your turret has been destroyed. Your inhibitor has been destroyed. An enemy has been slain.
Now and forever.
been slain. An ally has been slain. Your team has destroyed an inhibitor.
as a dependency. Now, normally, if I wanted to run this application directly on my computer, I'd first of all need to run npm install in this project directory. So I'd open up a terminal and type npm install, and that would install the project dependencies inside this project folder in a node modules folder. And then after that, to run the application, I'd just type node app.js, which is the name of the file I want to run. And that would start the application running directly on my computer. And it would be using the node version that I have installed on my computer. But we don't want to do that. We want to run the application inside an isolated container with its own version of node running inside it. So to do that, we need to make an image. So let's start now by making that Docker file in the root of this project of Node and Linux distribution we want the container to run. And then after that, the extra layers, which will be to copy this source code and all the dependencies into it, and then some extra information too. And again, the way we make this image is by first making a Docker file. So let's start now by making that Docker file in the root of this project folder. So the name of the Docker file is just Docker file with a capital D and no extension at the end of it. And remember, this Docker file is like a set of instructions which tells Docker how to create a specific image with all of its different layers. And each instruction is going to be on a different line inside this file. And generally speaking, each line in a Docker file kind of represents a different layer in our final image. Now, before you start actually writing this out, it might be a good idea to install the Docker package for VS Code. So if you want to install that, go to extensions and then just search for Docker up here, and it's this package right here. So click install and you can read about it right here. So install that first of all, then we can start to write out this file. So the first instruction, the first layer of our image is going to be the parent image, the node image that we can download from Docker Hub. So this goes at the top of the file because it will be the first layer or the initial layer of the image that we want to create. Now to do this, we simply write from in capital letters and then the name of the image that we want. In our case, that's going to be node and then a colon and say 17-alpine. So what this line says is that to begin with, we want to pull in the node image into our image as the initial layer. So when we run this file later to create our image, it will pull in the node image first of all, and it's going to pull it either from the Docker Hub repository if we haven't already downloaded it, or our own computer if we have. Now, we downloaded a node image, but it wasn't exactly this one. It was kind of the default version of that image, the latest one. But this one now has this tag, 17-alpine, which means get version 17 of node and use the Alpine distribution of Linux, alright? So it's going to download this from Docker Hub. So that is our initial layer, parent image. And to add a parent image like this as the initial layer, remember we use the from keyword at the top of our Docker file. So then on top of this, we also need to add our own additional layers. Now the next layer I want to add is to copy all of our source code into the image. So this app.js file and these JSON files as well. And to do that, we say copy in capital letters, then a dot, then a space, then a dot again. But what does this mean? Well, first of all, we say copy, which means copy some file to the image. And then the first dot is a relative path to the directory I want to copy my source file from. And since those source files are in the same kind of root directory as the Docker file, then the path is just going to be a single dot, which means the current directory. If all my source code was in a source folder over here, then instead of just a dot, it would be dot and then / source. Now the second dot is the path inside the image that I want to copy my source code to. Remember, I said that images have their own folder structure. So right now, we just say dot, which means copy into the root directory of the image that we're creating. Now, a lot of the time, we don't copy into the root directory because it might clash with other files or folders inside that root directory. So instead, we could say copy to a path which is / app, for example, and then this would copy our source files into a new folder called app inside the image, alright? So, the next layer of the image would be all the dependencies that we need to install on the image. Now, to install dependencies into a project, we run npm install, and we can do a similar thing to the image that we make. We're allowed to specify commands that we want to run in the image as the image gets built, so at build time. And to specify a command, we'd use the run instruction. Now, the command that we want to run is npm install, which installs all the dependencies listed in the package.json file. Remember, we copied that file over to the image in the previous layer. So this run instruction right here tells Docker to run a command on the image itself as this layer is being added on while the image is being built. And so then all the project dependencies will be installed onto the image as well. But there is one slight problem. The the command is going to be run inside the root directory of the image. But our package.json file got copied to an app folder. So that means that when this command gets run in the root folder of the image, it won't see the package.json file in that folder, and therefore it won't install the dependencies. So for this to work, we need to run this command in the same directory as our package.json file. So that's inside the app folder, right? And the way we do that is by specifying a working directory for the image. So the way we do this is by adding a work dir, which stands for work directory, instruction to the Docker file. And I'm going to place this at the top just underneath the first instruction, so that every instruction after this can use that working directory. And for a value, I'm just going to say /app. So what does this working directory do for us? Well, it tells Docker that when we run commands on the image in future after this instruction, or if we specify paths inside the image, to do it from this working directory. So now when a command is run, like this npm install, it will do it from inside the app folder. So that is one problem now solved. But there is one other change that we need to quickly make now that we have this working directory. It's the path that we want to copy to right here, because this is now a path relative to that working directory, which means that the source code will now get copied into /app and then /app again. So to solve this, we can just replace this with a single dot, and that means copy to the root directory relative, remember, to the working directory now, and so now everything should work correctly. So again, we can specify a working directory so that any commands that we run or any paths that we specify after this instruction are done relative to this working directory. Now, there is one more instruction I'm going to create, and that's another command to actually run the application in the container. Now, to run this node application, we run the command normally node app.js in the terminal, right? So you might think that we just add another run instruction right here at the bottom to say node app.js, but we don't do that. Let's think about why not. When we add a run instruction, it runs a command as the image is being built, so at build time. And remember, the image is not a running application, it's just a blueprint for a container. And the container is the thing that actually runs the application. In other words, it's a running instance of the image. So it makes sense to use the run instruction for installing dependencies at build time onto the image as the image is being created. And that way they are included in the image and ready for when we run the container based on that image. But it doesn't make sense to run the node app.js command at build time, because we're not trying to run the application when we're building the image. We're just making the image, right? And instead we want to run the node app.js command when we have a running instance of the image inside the container. So how do we specify this? Well, instead of using the run instruction, we use an instruction called CMD. And CMD allows us to specify any commands that should be run at runtime when the container begins to run. But the way we write this command is a little bit different. We write the command as an array of strings in double quotes. So the first one would be node, and then the second element would be app.js. And then when the container runs, this command will be run right here, which is node app.js, and that is going to spin up our application inside the container. Alright, so now there is one more thing I want to add to this Docker file, and that is an expose instruction, which tells Docker which port the container should expose. Because remember, inside the app.js file, when we start at the server, we listen for request on port 4000. Now, this app is going to be running inside the container, so the port is going to be owned by the container as well, not our computer, but by the container. And to make requests to this API, we need to send them to the container using the port number. So in the Docker file, we can add an instruction which tells Docker what port is going to be exposed by the container, which in our case is going to be port 4000. Now, this expose instruction is kind of optional. We only really need it here if we're going to be running images and spinning up containers using the Docker desktop application, because Docker desktop will use this information in the Docker file to set up something called port mapping later on, and we'll learn about that later as well. But if we're running containers from the command line, then it's not really needed. But I still like to add it so that at a glance at this Docker file, I can see which port is going to be exposed for this application. So I'm going to keep it in, and that's pretty much it for the Docker file. So we specify the parent image at the start, as the first layer, and then we specify a working directory of the image, and then we copy over all the source files, and then we run an npm install command at build time to add all the dependencies to the image, and then we say expose port 4000, and then finally we specify a command that should be run only when the container based on this image is run. And the final step is to actually build this image, and that's really simple to do. We just have to run a single Docker command in the same directory that this Docker file is in. So open up a terminal and make sure you're in the project directory down here, the API directory. If you're not, just cd into the API folder. And then type Docker, and then we use a command called build, so Docker build. And then after that, we can use a flag -t, which stands for tag. And this allows us to basically give the image a name, which I'm going to call my app. And then after that, we'll put a dot at the end. Now, the dot is a relative path to the Docker file from the directory we're in inside this terminal right here. And since we're in the same directory as the Docker file, then the path is just a dot to say this current same directory that we're in. So now hit enter, and then this is going to go through each of the instructions in the Docker file and do each one in turn. And each time it does one of those, it's essentially adding a new layer to the Docker image that we're creating right now. And you can see each of those steps happening as you watch the build process in the terminal. Alright, so once that's all done, the image is created. And we don't see any extra file in this project to represent that image anywhere at all. It's stored away for us in a special Docker folder on our computer. But if we open up Docker desktop, then we can see this extra image now listed right here with the name that we gave it, my app. Awesome.
I'd rather make mistakes than make nothing at all. anyone notices.
Not in defiance. Like rampage.
Look out!
Double kill.
Don't blink!
Shit. There are limits. Haven't found them yet.
An animal has been slain.
Step right up. Look out!
An enemy has been slain. Shut down. Your turret has been destroyed. An enemy has been slain.
Look out!
Your team has destroyed a turret.
Time as any to act reckless.
Unstoppable.
Look out!
Every second matters.
Dominating.
Look out!
You have slain the enemy.
Never had luck. Never did.
Don't get it! Look out!
Leon must have been a fun guy.
Victory!
Running instance of the image. So it makes sense to use the run instruction for all dependencies into a project in capital letters, then the root directory of the image that we're creating. So this app.js file and these JSON files as well. And to do that, we say copy in capital letters, then a dot, then a space, then a dot again. But what does this mean? Well, first of all, we say copy, which means copy some files to the image. And then the first dot is a relative path to the directory I want to copy my source files from. And since those source files are in the same kind of root directory as the Docker file, then the path is just going to be a single dot, which means the current directory. If all my source code was in a source folder over here, then instead of just a dot, it would be dot and then / source. Now the second dot is the path inside the image that I want to copy my source code to. Remember, I said that images have their own folder structure. So right now, we just say dot, which means copy into the root directory of the image that we're creating. Now, a lot of the time, we don't copy into the root directory because it might clash with other files or folders inside that root directory. So instead, we could say copy to a path which is / app, for example, and then this would copy our source files into a new folder called app inside the image, all right? So the next layer of the image would be all the dependencies that we need to install on the image. Now, to install dependencies into a project, we'd run npm install, and we can do a similar thing to the image that we make. We'd use the, remember, we copied that file over to the image we want to run is npm install, which installs all the dependencies listed to run a command on the image as well, JSON in that file. Do this under or if we specify paths inside the image, to do it from Docker working directory. And for a value, I'm just going to say /app. So what does this working directory do for us? Well, it tells Docker that when we run commands on the image in future after this instruction, or if we specify paths inside the image, to do it from this working directory. So now when a command is run, like this npm install, it will do it from inside the app folder. So that is one problem now solved. But there is one other change that we need to quickly make now that we have this working directory. It's the path that we want to copy to right here, because this is now a path relative to that working directory, which means that the source code will now get copied into /app and then /app again. So to solve this, we can just replace this with a single dot, and that means copy it to the root directory relative, remember, to the working directory now. And so now everything should work correctly. So again, we can specify a working directory so that any commands that we run or any paths that we specify after this instruction are done relative to this working directory. Now, there is one more instruction I would create, and that's another command to actually run the application in the container. Now, to run this node application, we'd run the command normally node app.js in the terminal, right? So you might think that we just add another run instruction right here at the bottom to say, no, the image is being the thing that actually runs the app. Build do that. Let's think about why not. When we add a run instruction, it runs a command as the image is being built, so at build time. And remember, the image is not a running application, it's just a blueprint for a container. And the container is the thing that actually runs the application. In other words, it's a running instance of the image. So it makes sense to use the run instruction for installing dependencies at build time onto the image as the image is being created. And that way they're all included in the image and ready for when we run the container based on that image. But it doesn't make sense to run the node app.js command at build time, because we're not trying to run the application when we're building the image. We're just making the image, right? And instead we want to run the node app.js command when we have a running instance of the image inside the container. So how do we spec any commands that should be run at runtime when quotes? So it will be run right here, which is node app expose listen for request on port 4000. Now this app is going to be running inside the container, so the port is going to be owned by the container as well, not our computer, but by the container. And to make requests to this API, we need to send them to the container using this port number. So in the Docker file, we can add an instruction which tells Docker what port is going to be exposed by the container, which in our case is going to be port 4000. Now, this expose instruction is kind of optional. We only really need it here if we're going to be running images and spinning up containers using the Docker desktop application, because Docker desktop will use this information in the Docker file to set up something called port mapping later on, and we'll learn about that later as well. But if we're running containers from the command line, then it's not really needed. But I still like to add it so that at a glance at this Docker file, I can see which port is going to be exposed for this application. So I'm going to keep it in, and that's pretty much it for the Docker file. So we specify a parent image at the start as the first layer, then we specify a working directory of the image, then we copy over all the source files, then we run the npm install command at build time to add all the dependencies to the image, then we say expose port 4000, and then finally we specify a command that should be run only when the container based on this image is run. Now the final step is to actually build this image, and that's really simple to do. We just have to run a single Docker command in the same directory that this Docker file is in. So open up a terminal and make sure you're in the project directory down here, the API directory. If you're not, just cd into the API folder. Then type docker, and then we use a command called build, so docker build. And then after that, we can use a flag -t, which stands for tag. And this allows us to basically give the image a name, which I'm going to call my app. And then after that, we'll put a dot at the end. Now, the dot is a relative path to the Docker file from the directory we're in inside this terminal right here. And since we're in the same directory as the Docker file, then the path is just a dot to say this current same directory that we're in. So just one of those, it's essentially adding a new layer to the Docker image that we're creating right now. And you can see each of those steps happening as you watch the build process in the terminal. It's stored away for us in a special Docker folder on our computer. But if we open up Docker Desktop, then we can see this extra image now listed right here with the name that folder on our computer. But if we open up Docker Desktop, then we can see this extra image now listed right here with the name that we gave it, my app. Awesome. Alright then gang, so we have this Docker file now, and we also created an image from that Docker file in the last lesson. And we can see that image if we open up Docker Desktop, and we can see it right here. Now at the minute, you'll notice inside our project folder, in VS Code, there's no node modules folder, even though we have dependencies for this project. But that's okay, because we're not going to be running this project directly on our computer inside this folder. Instead, we're going to be running the image that we created via an isolated container later on. And all the dependencies were installed on that image because of this run npm install instruction right here. So what that did was create the node modules folder inside the image and put all the dependencies inside that folder. So it really doesn't matter that it's not here inside this project folder on our computer. Now, sometimes the node modules folder will exist in your local project on your computer. For example, if I come to the terminal and I type npm install inside the project directory, it's going to look at the package.json file and install all of the dependencies, and it's going to put them inside a node modules folder in this project directory. And by the way, you would need Node.js installed on your computer in order to run this command. But don't feel like you need to go out and install it. This is just a demonstration, and beyond doing this, you won't really need Node installed or anything else. Anyway, now we've installed all the dependencies, we can see we have this node modules folder inside our project right here on our computer. And if I was to create another image based on this project right now, then in this copy step, it would copy the entire node modules folder over as well, because we're just copying over everything in this directory. Now, that's bad for two reasons. First, we already installed the dependencies on the image in this previous step where we said npm install, and that creates a node modules folder directly on the image. So if we copy this node modules folder later on at the copy step, then it's just going to replace the one already created on the image. And that could be a problem if some of the packages inside the node modules folder over here are out of date. So that's the first problem, right? The second reason this is bad is because it's going to take more time then to create the image and copy over all the files, because it has to copy over a load more stuff inside the node modules folder, which don't really need copying over. So ideally, when we're creating the image, we don't want Docker to copy over the node modules folder if there is one. And we can get around that by making a docker ignore file in the project directory. So to do this, we just create a new file and we call it .docker ignore. And then inside this file, we can specify any files or folders that we want Docker to ignore when it copies them over to the image. So I could say right here, node_modules. And that means that when we copy over the files, Docker will ignore the node modules folder and it won't now copy that to the image. Now, if you wanted to add other things to this file, you could, and they wouldn't get built into the image either. For example, logs or sensitive information that you don't want going inside the image itself. And if you wanted to exclude any file with a certain extension, like an MD extension, then you could just say asterisk, then .md. So this means basically ignore any file name, which is denoted by the asterisk, with an extension of MD. Now, I'm just going to leave it as the node modules for this docker ignore file. And that's pretty much it for now. So now when we build this image in the future, it won't include this node modules folder inside the build image, even though it's inside our local project here. So just remember that if you do have node modules locally in your project, you can tell Docker to ignore that folder by using a docker ignore file. Alright, so next up we're going to take a look at how to... Alright then, so we already know now how to make an image, and in Docker Desktop we can see that image listed right here in the Images tab. Now we can run that image to create a container, which then runs our application by clicking on this run button right here, and then Docker will take that image and it's going to run it, and in turn that creates a container for us. Now when we do this, we get some extra settings that we can set, and this step is quite important. So first of all, we can give the container a name. I'm just going to call it my app1, then underscore, and C for container. And then also we can specify a port by which we can reach this container on our own machine. So think about it. In our application, we have a node server which was listening to requests on port 4000, right? Let me just bring up VS Code to show you that inside the app.js file. So you can see that right here we listen for requests to port 4000. But that is a port that's going to be exposed by the container. It's not a port exposed by our computer directly that we can access directly via localhost. So if I was to visit localhost port 4000 in the browser, then it wouldn't reach our application because again, this is not a port that's exposed directly by our computer. It's one exposed by our container. But Docker allows us to map a localhost port number to the port exposed by the container. So I could type 5000 in here if I wanted to, and then that would map port 5000 on localhost to port 4000 exposed by the container. And then if I was to visit localhost port 5000 in the browser, it would then hit our application because that localhost port is now essentially mapped to the container port number. Now typically we keep the port numbers the same to avoid any confusion. I just wanted to demonstrate that these don't have to be the same. So I can change this to 4000 now and it would do exactly the same thing, but this time it would map localhost port 4000 to port 4000 exposed by the container. And by the way, this port mapping option on Docker Desktop is only going to be there if you added the expose instruction in your Docker file. If you didn't do that, then it won't be here. So we also get an option for volumes, but we haven't touched on those yet, so we'll leave that blank for now. And now, if we hit run, then it's going to start up the container. And then we should see that container listed in the containers tab right here. And any containers that are currently running should have this kind of green coloured icon next to it. For any containers not running, this is probably going to be grey instead. So we can open this up in a browser now by clicking on this icon right here, and that's going to now take us to localhost port 4000. So inside the browser, we can see the response that we get from the application, the JSON data. So this is all working now. We have the application running in the container in isolation, and we can also reach that from a browser on our computer. Awesome. Now, if I close the browser, we can still see that the container is still running right here. Now, we can stop the container by clicking the stop button, but this doesn't delete the...
Loyalty is earned. Welcome to Summoner's Rift. 30 seconds until minions spawn. I make my own. Heroes go high. Minions have spawned. Slain. You have slain an enemy.
Laws or whatever works at the time.
Heads up. Better duck. Take this. Heads up.
It's not feeling if they're dead. Honor is the rust on a dull blade.
Better duck. Take this. Heads up.
I won't die for one.
Better duck. Back off. Take this. Heads up.
I've got value. They stack up nicely.
Better duck.
Has been slain. You have slain an enemy. Enemy double kill.
Kills come and go.
Heads up.
An enemy has been slain.
Better duck. Take this.
An ally has been slain.
Heads up. Better duck.
Wealth is mine with burden.
Take this. On the way. Heads up.
can't take the desert.
Take this. Heads up. Better duck.
Enemy killing spree. An enemy has been slain. Ally has been slain. You have been slain.
Light strikes everything.
Loyalty is earned.
Rampage.
Heads up. Better duck.
I go where the trouble is.
An ally has been slain. Enemy killing spree.
I make my own fortune.
Heads up. Better duck.
Heroes go. You've got a problem. I've got a friend.
An ally has been slain. Enemy double kill.
Laws or whatever.
Down.
Shine.
Everyone has a price.
Turret plating will soon fall.
Better duck. Take this.
It's not stealing if they're dead.
Heads up. Back off. Better duck.
You have slain an enemy.
Take back what's ours.
An enemy has been slain. Your turret has been destroyed. An enemy has been slain.
Heads up.
Honor is the rust on a dull blade.
Better duck.
An ally has been slain.
Heads up. Better duck.
I'll fight for a cub. I won't die for one.
Take this. Water spout.
Shut down.
Heads up. Better duck. Back off.
Kings come and go, but gold stays.
Heads up. Better duck.
An enemy has been slain.
Take this. Heads up.
Enemy Enemy double kill.
Heads up.
Back off. Your team has destroyed.
Better die. Take this.
My kind of friend.
Visor.
Nice try.
Double kill.
Heads up. Better duck. Take this.
You can't take the desert.
Dominating. An enemy has been slain. An enemy is godlike.
The only thing I want to do
An
is
enemy has been slain. An enemy legend. You have been slain.
I make
Double
my
kill.
nice try.
Better duck.
Heroes go hungry.
An ally has been slain. Your team has destroyed a turret. An enemy has been slain. An ally has been slain. An enemy has been slain. You have been slain. An ally has been slain. Enemy double kill. An enemy has been slain. You have been slain.
Heads up.
Has destroyed a turret.
Better duck. Take this.
It's not stealing if they're dead.
Heads up.
Honor is the rust on a dull blade.
Better duck.
I'll fight for a cause. I won't die.
An ally has been slain. An enemy has been slain. Enemy killing spree. An enemy has been slain.
I've got values. They stack up nicely.
Heads up.
Crack 'em like it's hit.
Better duck.
An ally has been slain.
Take this.
An enemy has been slain.
Heads up.
Shut down.
Duck.
Has been slain. Shut down.
Get paid and get out.
Shut down.
Better duck.
Nice try. Wealth is my kind of burden.
An enemy has been slain.
Heads up.
You can't touch the desert.
Take this. Water spout.
An enemy has been slain.
Look up to the sky.
Double kill.
Better duck.
Your team has destroyed an inhibitor. Your team has destroyed a turret.
container is still listed here, it's just not running at the moment. Now we're going to see how to delete containers permanently later on, but for now I also want to show you how we can do all of this stuff, how to run images to start a container and how to stop a container from the command line as well. Alright, so we saw that we can run an image in Docker Desktop to create and run a container based on that image. We can also do the same thing from the terminal, as well as stop containers too. So first of all, to run an image to create a container, we need either the ID of that image or its name. Now we can find out by listing all the images that we currently have, and we can do that by typing in the terminal docker images and then pressing enter. And then right here, we can see a list of images that we have. Now right now that's only 2 images, but later you might have more. And we can see the name or tag of the image right here, and also the ID of the image as well. So I'm going to use the name of the image to run it, which is my app. So to do this, to run an image, we say docker run, and then the name of the image, or the ID of the image that we want to run. In our case, the name of the image is my app. Now before we hit enter, I want to do one more thing. I want to give the container that we're about to run a name. And to do that, we need to go back before the image to add some options. So any flags or options that we add go directly after the run command and before the image name or the ID. So in this case, the option or the flag that we want to add is --name, and this allows us to name the container we're about to make. So I'm going to call this myapp_container1, and the C stands for container, but you can call it what you want. And that's all we need to do. So now we can just hit enter to create this container. And now we can see that the app did start running in that container, because eventually you'll get this message that says listening for request on port 4000. So now what do you think is going to happen if we try this in a browser? Well, let's give it a whirl. So if I visit localhost port 4000, we see that, well, it doesn't actually work. And the reason is because of what we talked about earlier. The port listening for requests is exposed by the container, not our computer. So we can't directly access it via localhost like this. Remember, we need to map our localhost port to the container port that's exposed. And we did that in the Docker Desktop tool, and we can also do it from the command line as well. So then, now in VS Code, we can see that this container is requests, and we're attached. And then, first of all, we're running right here. It says the container ID, image, Docker, in a name that we want to stop. So it's the process. So to do that, we type docker run, just like the host computer, or to access the container port via port app. And actually, one more thing before we hit end, terminal is essentially detached from the process. All right. So our terminal is essentially detached from the process. All right. So container in detached mode, our terminal is essentially detached from the process. All right. So now we can hit enter to run this container. And after a few seconds, we can see the container will be up and running, and it will be listening for requests again at port 4000. But this time we should be able to access it using localhost port 4000 because we added that p flag. And also we can see that our terminal isn't blocked anymore either because we added the detached flag as well. Alright, so now in the browser at this address, localhost port 4000, we can now see our response. Cool. Alright then, so now every time we run docker run to run an image, we create a new container. That's creating a brand new one each time, and we give it a name. And we can see that if we open up Docker Desktop, we can see all of these containers we have right here. So every time we do this, we're making a new container. Now, we can, if we want to, stop a container and then restart it. So first of all, what I'm going to do is say docker, and then I want to stop the container, and the one currently running is this thing right here. So I can copy that, paste it in, and press enter. And this will hopefully stop the container first of all. Might take just about 30 seconds or so. And then when it has stopped, we can restart one of the containers that we already have. Now, let me just show you something. If I say docker ps, that listed out all the containers, right? If I press enter, notice we don't actually see any containers there, even though we do have a lot of containers. We have all these containers right here. Now, this ps thing right here only lists out containers that are currently running. If we want to see all of them, we can say docker ps and then -a to say all, and now we can see all the containers, right? So if I wanted to just rerun or restart one of these containers, I could do. I could restart this one right here. And to do that, I could just say docker and then start this time, not run, because docker run runs an image to create a new container. Docker start can start up an existing container. So docker start and then myapp and then _c2. Now this time we don't need to reconfigure the port mapping or anything like that. Run could read it out, even though we do have a lot of containers. We have all these. And then when it has stopped, we can restart one of the containers that we already have. Now, let me just show you something. If I say docker ps, that listed out all the containers, right? If I press enter, notice we don't actually see any containers there, even though we do have a lot of containers. We have all these containers right here. Now, this ps thing right here only lists out containers that currently are running. If we want to see all of them, we can say docker ps and then -a to say all, and now we can see all the containers, right? So if I wanted to just rerun or restart one of these containers, I could do. I could restart this one right here. And to do that, I could just say docker and then start this time, not run, because docker run runs an image to create a new container. Docker start can start up an existing container. So docker start and then myapp and then _c2. Now this time we don't need to reconfigure the port mapping or anything like that because that was already created for the container when we ran the image. So all of that information is still kind of stored for the container. All we have to do is start it back up. So if I press enter, hopefully in a second or so, it's going to run the container. Again, remember we added the detached flag, meaning this is not blocking the terminal now, it's putting detached mode. Now if I open up Docker Desktop, we can see that this thing now is running again. And if I open up the browser and bring this over here, we can see everything is running. So now we've just restarted that server that we had, okay? So my friends, that's how we can run images to make containers and then map container ports to our host computer. And again, you can do all of this with either Docker Desktop or from the command line. We're going to mainly be sticking to the command line from now on. Next up, we're going to talk about something called layer caching.
An ally has been slain. Enemy double kill. slain.
It's too late for mercy.
Double kill. An ally has been slain.
Playtime's over.
Shut down. Enemy killing spree. Enemy double kill.
They respond to their
Slain.
No one will stand in my way. Let me give you
Ally has been slain. An ally has been slain. Enemy double kill. Enemy rampage. An enemy has been slain. Ally has been slain. Shut down. An ally has been slain.
They're mine now.
An ally has been slain. An enemy has been slain. Double kill. You have been slain. Unstoppable. Your turret has been destroyed.
Oh, hello!
Your team has destroyed the turret. Shut down. Your team has destroyed a turret. An ally has been slain.
They're mine now.
Ally has been slain. Killing spree. An enemy has been slain. An ally has been slain. An ally has been slain. Double kill. An ally has been slain.
They've exhausted
An
their
ally has been slain.
mine now.
An enemy has been slain. Destroyed. Your team has destroyed a turret. You have slain an enemy. Your team has destroyed an enemy. has been slain. Enemy's inhibitor has been slain. Victory!
Or anything like that, because that was already created for the container when we ran the image. So all of that information is still kind of stored for the container. All we have to do is start it back up again. So if I press enter, hopefully in a second or so, it's going to run the container. And again, remember, we added the detached flag, meaning this is not blocking the terminal down here because we're in detached mode. Now, if I open up Docker Desktop, we can see that this thing now is running again. And if I open up the browser and bring this over here, we can see everything is working. So now we've just restarted that server that we had, okay? So, my friends, that's how we can run images to make containers and then map container ports to our host computer. And again, you can do all of this from either Docker Desktop or from the command line. We're going to mainly be sticking to the command line from now on. Next up, we're going to talk about something called layer caching.
Every adventure is better with the friends.
Alright, so recently Firebase introduced version 9 of the library, and the way we use version 9 is a bit different to how we've been using Firebase in the past with previous versions. But before I get into those differences and talk about them, I wanted to give everyone who's completely new to Firebase a whirlwind tour of what it is. So, Firebase is what's known as a backend as a service, and that means that it provides backend services like a database, authentication, file storage, cloud functions, hosting, and other things as well, and we can plug those services directly into our front-end applications or websites to make use of them. And Firebase then takes care of all of the server-side logic and heavy lifting so that we as developers don't need to focus much on it at all. So it's an alternative to setting up our own backend infrastructure using tools like MongoDB and a Node.js server. So instead, Firebase handles all of that for us, and we can focus more on the front end of our applications and the end user experience. It's really simple to get started with, and most of its features are completely free for small personal websites. So, to use it, the first thing you need to do is head to the Firebase website at firebase.google.com and sign up for a free account. You should see a sign up button in the top right. Alright, so recently Firebase introduced a server. So instead, Firebase handles all of that for us, and we can focus more on the front end of our applications and the end user experience. Alright, so recently Firebase introduced need to do is head to the Firebase website at firebase.google.com and sign up for a free account. You should see a sign up button in the top right somewhere, and once you've done that, you should see a link instead that says something like Go to Console. So click on that to go to the Firebase console, and your Firebase console is where all of your Firebase projects are listed. Generally speaking, for each different website or application that you create, you normally have a new Firebase project for it. Anyway, before we make a new project, first I want to talk about some of the differences between Firebase version 8 and the new Firebase version 9. So the major change in version 9 of Firebase is that it now adopts a more modular and functional approach, meaning that we only import the Firebase functions that we need from the libraries and not those we don't need. In contrast, version 8 used a more object-oriented approach where we call those functions or methods directly on Firebase objects. But by using a more functional approach and only importing the functions that we need, we can take advantage of something called tree shaking, which is where any unused code or functions can be removed from our final bundled JavaScript file. To do that, we'll need to use a module bundler like Webpack or Rollup, but we'll talk more about that in the next lesson. For now, the main takeaway point is that using Firebase 9 in this functional way means more optimized output code and a smaller file size. Now, if we quickly take a look at the code examples on the Firebase docs, we can see the difference in how we use Firebase 8 and 9 by switching between the two tabs. And you'll notice that when we select version 9, the individual functions that we need are imported from the Firebase libraries. But when we select version 8, the functions are called directly on the Firebase object. So this is the major difference between how Firebase versions 8 and 9 differ. And we'll be seeing how to use version 9 using the Firestore database and the Firebase auth service in this series. First up though, we need to set up a module bundler like Webpack in order to use the new Firebase version and take advantage of that tree shaking feature.
30 seconds until minions spawn. First blood.
Let's make them notice. Go blink!
Minions have spawned.
Neither a Piltover in Dawn.
Dawn is the future. Think fast! Back before anyone notices.
Ally has been slain.
Time is not on your side. Blink!
Has been slain.
They're all in. Haven't found them yet. Only once? Now just remember.
Heads up.
Progress doesn't belong to us. Heads up!
Better duck.
Think fast!
You have slain an enemy. Double kill. An ally has been slain. You have been slain.
Back to going forward.
Ally has been slain.
Responsible. Time doesn't heal.
Heads up.
Slain an enemy. You have been slain.
Heads up.
Enemy killing spree.
Heads up! Think back! Right up! There are always consequences. Look out!
Better duck.
I wish I stayed here. We make the future. Come get it! Heads up! Second first time for everything. Pumpkin! Look out! Right! Go! Look out! Get right up! Go! Pumpkin! Cat! No one can see us. Back before anyone notices.
Pay no attention to the trap.
Get right up! Look out!
Turret plating will soon fall. Enemy rampage.
Look out! Show me something new.
Shut down. Double kill.
I wish I stayed here.
Is unstoppable.
Step right up. Pumpkin!
You have been slain. Shut down. An enemy has been slain. An ally has been slain.
Back off. I'll help you this time.
Has been slain. An enemy has been slain.
Patience? What's that? Step right up.
Enemy double kill. You have slain an enemy. Your turret has been destroyed. Your turret has been destroyed. An ally has been slain.
Not quit until you're right.
You have slain an enemy. Shut down.
Taking a breather. Make me repeat myself.
An ally has been slain. Your turret has been destroyed. slain an enemy.
I need to rethink a couple things. Every second matters. Back to square 7. Go! Step right up!
Take this. Better duck.
Heads up! I finished what I started.
Has been slain.
Okay. Look out! Don't blink!
Shut down.
We're doing the hard
An
way.
enemy has been slain.
Think back! Step right up! Tomorrow's the last day. Go! Look out!
An enemy has been slain.
I like hitting you. Back for an
An ally has been slain. Enemy double kill.
never. Step right up.
I'll protect you.
Come get me. Don't blink. Step right up.
An enemy has been slain.
Together.
Worked in another timeline.
Enemy double kill. An ally has been slain. Your turret has been destroyed. Your turret has been destroyed. Your inhibitor has been destroyed. Executed.
Heads up. Look out. Go. I do my own sins. Think back. Look out. I owe them nothing.
An enemy has been slain.
Go! Cat! Look out!
Your team has destroyed a turret.
Let's make them notice. Go!
Your team has destroyed a turret.
Zon is the future. Look out!
An enemy has been slain.
Look out!
Shut down. Enemy killing spree. An ally has been slain. An enemy has been slain. An enemy has been slain. Shut down. Killing spree. Shut down. An enemy has been slain.
There are limits. I haven't found them yet. Look out!
The enemy has been slain. An ally has been slain.
Look out!
An enemy has been slain. Your inhibitor is
I wish I stayed
Your
here.
team has destroyed a turret.
Back to going forward.
Your team has destroyed a turret.
Step right up. Look out! Step right
team has destroyed an inhibitor.
Yep, that went exactly how I did it to go. Don't blink! Look out! Heads up! Time doesn't heal. Yeah. Go! Look out!
An enemy has been slain.
Go!
An ally has been slain. Killing spree. Shut down. You have slain an enemy.
Look out! Time is not on your side. Go! Think back! Look out! Merciful arrow!
Has been slain. A summoner has disconnected.
Just two more things really quickly before we start. First of all, I've created course files for this series, and you can find them at this repo right here, Getting Started with Firebase 9. So the link to this is going to be down below, and there's a different branch for every lesson in this series. So if you want to see the code for lesson 7, for example, select the lesson 7 branch, and you're going to see all the code and folders right here. If you want to download a zip folder of this lesson, you can do that by clicking on this button, and then going to download zip. Alright, so also, you'll need Node.js installed on your computer on the NetNinja website, NetNinja this month half price when you use this promo to share, subscribe, and like